Yes, sure.
Okay, good evening, everyone. Welcome to fifth live session for the course Functional and Conceptual Design from IIT Madras. My name is Neelarnab Dutta. I am a PhD scholar and a PMRF fellow from Department of Design, IIT Guwahati. Okay. So the agenda for this class is to help you with your week 5 assignments. So have you gone through the lecture videos of week 5? Because the deadline for assignment submission is tomorrow, that is 31st August. And if you have not covered the assignments and the video lectures, please go through those. In today's class, since the nature of the assignments are objective, so I'll be covering key concepts that will be helping you with in solving the assignments. Okay. So last week, in the last live session, we learned about different types of customer needs. Okay, and those were direct needs, lateral needs, constant, variable, and niche needs. So what are direct needs? You can use the message box to answer my questions. Okay, so let me give you an example.
Yes, sorry for interruption. Direct needs are those needs which are directly, you can say, influence the demand for a product, such as if the functionality which you can say basic functions that are required in a product are the direct needs, you can say, and
Okay,
just
so
like
let's take an
yes.
example like washing machine.
Yes.
Okay, so what
So,
will be the
and
direct
for
needs?
example, in a washing machine, the direct need is it should be able to wash the clothes, the basic thing.
Okay, and what
And
are the lateral needs?
lateral needs, you can say how the product is being delivered to you. It should not be damaged in a damaged condition, or you can say it should have a basic modes in it. You can say different modes.
Okay. So basically, in direct needs, we consider customer needs, whereas in lateral needs, we consider the life cycle of a product, and we assess the various stakeholders and see in the life cycle of product delivery to product end where there are requirements or needs to make the this life cycle sustainable. Okay, for example, as you said, like from manufacturing to the distributors, the product should be easy to delivery. Okay, so that is one of lateral need. Similarly, easy to repair, okay, easy to maintain, can be all lateral needs. And constant needs are those needs which are remain constant across different consumers, like different customer feedback. For example, as you said, washing, that is the primary need that everyone will be asking about. That's why it will be a constant need. Okay, so these three types of need, constant need, then variable needs, and niche needs, are actually kind of needs that actually derive from direct and lateral needs. Okay, so these are basically the reasons why they exist is basically because of variation in customer requirements. Okay, so similarly, variable needs can be someone may need, in a washing machine, probably someone need a fully automatic. Okay, someone may need a semi-automatic. So those are like, those can vary from person to person. So when you design a washing machine for this kind of variability, then you need to design both, like one automatic washing machine as well as the semi-automatic, which is a bit bigger, and manually you need to transfer cloth to the rinsing cycle or the cycle. Niche needs are like if it is special needs. For example, someone may ask like no Bluetooth connectivity in order to visualize what's going on, how the clothes are washing or not. So someone may ask for camera facilities, and generally those are not addressed in the commercial products. However, if it's for a small segment of customer, then probably a designer may think about satisfying those requirements. Okay, so next, what we learned last week was a method called like dislike method. So, do you know why it is used for, and what is this?
Yes, in like and dislike needs, we actually try to find out the basic needs by asking several questions regarding a product with the end customers, like what he likes in the product, how is it useful for him, what are the dislikes, and from that we interpret certain logics so that we can modify the product in a much better way so that it can help the customer.
Okay, so basically we ask four type of questions. Okay, to every customer. One is typical use, typical use. One is like what they like about the product. First thing is like what they think about the typical use of the particular product. Second thing is like what they like. Third is what they dislike. Fourth is what they want to improve. Okay, so based on these requirements, actually we interpret the first level of needs, which I call interpret needs. Okay, and then mainly like and dislike method is useful for identifying direct needs. Okay, and do you know what is activity diagram?
uh, yes, in activity diagram actually, uh, sorry, can you elaborate? I just a little forgot about it.
Okay, so activity diagram is generally useful for identifying indirect or the the literal needs. Okay, okay, indirect and
Yeah,
literal
just
needs.
from which this we make a complete life cycle of the product, and we deduct things. What are the maybe primary needs and this lateral needs that may be associated with the product, right?
Yes, yes. So we consider a life cycle and different use case scenarios, different stakeholders, and we analyze the activities. Okay, so for example, at the distributor level, various activities at the consumer level, at the disposal level. Okay, various activities, manufacturer level, and when manufacturing to distributors also we consider the activities from distributor to consumer, also consider the activities similarly to the disposable. In all these activities we look for the requirements, like do you need anything that needs to be part of the design. For example, if you want something to make easy to transport and distribute, then you want to make this form factor a bit small and also stackable. Okay, so that multiple washing machines can be stacked one after another. So those design decisions can be used for such kind of literal needs that is easy to transport. Okay, and what is affinity mapping? uh, okay, let me answer. Affinity mapping is basically useful when we have lot of indirect needs and we try to categorize certain needs into a higher order need statement. Okay, for example, you can have easy to transport. Okay? You can also can have someone say portable, someone can say easy to store. Okay, so we can see that these all direct the designer into one single need requirement, which is probably the smaller form factor. So this is how we affinitize multiple uh, interpreted needs into broader needs. Okay. So because after we do such kind of need analysis, like using primary methods like dislike methods or activity diagram, we end up with more than like 5,000, 6,000 of need statements, and not all of them are unique. So we need to affinitize those. So we need to group them into certain clusters. Okay, so these are like individual clusters, and they actually give you the broad set of needs. It's very similar to set theory. Okay, and finally, in last class, we talked about product specification. So where actually we convert the qualitative information from the customer to something quantitative that will be helpful for designing a product. Do you know how to represent product specifications? What all we require?
In product specification is a collection of needs which we gather from interviewing these customers. Basic needs. It's a quantitative measurement of the basic requirement for a product. Uh,
Can you give an
this is,
example? So, for example, I
for
say,
example,
okay, you give.
yeah. For example, if I take a this T, you can say electric heater. So in you can say electric heater or yeah, in electric heater, it must be the specification will be the what are the range in which it will be it, providing us the sufficient heat, and what is the uh, operating voltage for it, and you can say uh,
Okay,
yes, the material also it's a specification quality. What kind of material is used for making that product, because it's determine the life cycle of that product.
okay. So remember, in every product specification, we have two entities. One is a matrix, and the other one is a value. Okay. That means when we say a customer need, for example, easy to transport is a qualitative information, right? There's nothing we can design about. However, when we convert it into product specification, we need a matrix. That means easy to transport. It can be weight, right? Or it can be size or volume. So these define actually the matrices, and then we have values. That means weight should be less than, for example, 50 kg. Size or volume should be less than 100 or 1000 centimeter cube. So when we come to product specification, we always need to come up with certain matrices as well as values, which can be later converted into design features. Okay, okay, good, that much is clear. Okay, in today's class, I'll be talking about what is target specifications. See, we have so many needs. Okay, so many needs that we come across when we do certain contextual inquiry with customers or users. We come across so many needs, and there can be so many different ways how a particular need can be converted into product specifications. But there should be some systematic and logical way of doing it. We cannot directly go from customer needs to a particular product specifications. Sometimes we may not know when it's a new product design, we may not know exactly how much the value should be or what the matrices should we should include. Okay, so remember, a product specification is always a matrix and a value. Okay, for example, if it is a weight, it is like 50 kg. If it is length, it is 5 centimeter. Okay, so that means we need to know exactly what sort of uh, specification finally we need to arrive at. Okay, so here is an example I discussed last in the last class. Like for example, assume that you are a designer and you are going to design a retro bike, like a classic, you know, like a, Royal Enfield. This is not classic, Royal Enfield Bullet. Okay, now this is Royal Enfield Bullet, but you want to design something in the scope of a classic bike.
Sorry, can you repeat the last line? Actually, my connection was lost.
Okay, so just imagine you are a designer and you benchmark one bike like a Royal Enfield Bullet, and you want to design a classic bike, okay, similar to Royal Enfield. And there are so many other competitors, but you want to design something like a classic bike, okay. And then you come across, you go for a contextual inquiry. So contextual inquiry means you go for need identification phase and you do a what is that? Uh, what is that process called? Like dislike method. Okay, you do a like dislike method. Then you did one activity mapping. Okay, and you arrive at certain needs. Okay, okay. So here are few. Okay, so can you give some more example? So I have sorted few. Uh, so these are some of the examples a customer might, want to improve or want to have in their designs. Okay, one is easy to balance. Okay, one is comfortable to ride. Then need a macho feeling. That's why you want a classic bike in this new era. Then there's something called long ride capability, because most of the users, they use these classic heavy bikes for long rides, probably to go to Leh Ladakh. And then it should be easy to service and repair, and easy to transport. Okay.
One requirement, although it is a classic bike, but with the changing this technologies, I would suggest that maybe customer need that navigation part in inbuilt in this bike also, because a lot of the times they have to put mobile phones in front
Okay.
with external gears. So yeah, it could be have a classical look and all, but yeah, integrated with that, it should be having a navigation display in it.
Mm-hmm. Okay, so can you classify these needs as direct or indirect, direct or lateral needs?
Thus, easy to balance, comfortable to ride, long ride capability, uh, easy to service and repair, all are direct need, because these are the must a person should be having. Yeah, but this like and this direct and direct, I guess it will be subjective in my context, because these are with my respect to demands.
Mm-hmm.
uh, and easy to transport will be, yes, definitely it will be went to latent uh, need, because we won't be caring that when it's a bike is coming, we should be care about it will be transported is in a ill manner. So yeah, easy to transport will be in latent need, and long ride capability and comfortable to ride must be in a direct need. Yeah.
Okay.
So it should be having a, yeah.
Okay, okay. So basically, the need can be both lateral need and direct need, depending upon who is letting you know that. For example, easy to transport can be for the customer itself. He may want the transport the bike from one location to the other. Probably the customer often do long like Leh Ladakh trips, so he need to easily transport the bike in a railway through railway, and then collect it at the other end. So similarly, the easy to transport can be from the distributor's perspective, and then it will be literally need. Okay. So if it is from the perspective of the customer, it is a direct need. If it is from the perspective of distributor, which is like no, not a direct end user, that's why it is under lateral need. So it is both lateral need as well as a direct need. Similarly, easy to service and repair is both lateral, no latent, or direct need. Need macho is direct need, you know, because it is the customer who actually wants it, so it's like dislike or improvement. So you are considering those from the like dislike method of interview, and these are some of the things actually customer want to be part of the bike. Okay. Suggest me few product specifications related to these customer requirements. How you will
And
make.
yeah, when it comes to product specification, as you said, and it must be having a metric and a value associated with it. So comfortable to ride should be must be
So
we must
for first.
specify the kind of seat we are providing with the, you can say, comfortable level, something rating, some kind of rating, with some kind of rating, and
For example,
long ride
seat.
capability. Sorry.
What you told about the easy to balance part, what you suggest as a product specification for easy to balance. Let's go one by one.
Hmm. Yeah, for easy to balance, actually, with in terms of bikes, I'm not much familiar in technical terms. But yes, I guess as the weight of the bike increases, the balancing capability also increases. I guess that's not a perfect answer, but maybe. So we can specify in terms of the weight of the bike what we are providing,
Okay.
and comfort, yeah, in terms of comfortable to ride, uh, definitely we can provide the soccer specification in for a comfortable to ride soccer specifications, that is it providing two sockers or single soccer system, uh, and need mature feeling in terms of mature feeling. Uh, Sorry, in major filling, may I get the answer from you
Yeah, so
in
let
this
me give
need
you give
material?
you
Yeah.
certain hint, right? Okay. See why we need a macho feeling. Okay, one is you want to feel something different in a crowd. Okay, and how you do you think a bullet, a bike like a classic bike, feel you different in a crowd. One thing is like the sound. Okay, the thumb sound. Okay, the duk 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 duk, that sound itself, there are a lot of bikers who want that sound to be loud. They change their silencers and they want to have that feeling, that macho feeling. Second thing is like the stance, the handlebars, the way the person actually sits, that also gives some sort of macho feeling. And this actually, we cannot, when we talk about product specification, we now have to talk from in terms of matrices and values. So weight is a correct matrix, as you told. You need to define certain values, for example, what 180 kg. Similarly, when you say seat cushion, that means seat cushion means what? Either you will be talking about the foam density, foam density or the thickness of the foam. You need to come to or you give a specification in terms of some values which are quantitative in nature. Thickness, for example, 10 centimeter. Foam density, for example, 10 uh, gram per centimeter cube. Okay, so this is like weight by volume. Thumb sound, maybe in terms of decibel, something like less than 60 or greater than 60 decibel. Okay. Similarly, for long ride capability, what do you think should be product specifications? Now you need to give me
For
answer
long
in.
ride capability, it must be yes. It must be specified the distance it can travel without interruption in a single go. You can say, or yes, just like that only. You can.
Oh,
It should be having this long capacity for petrol also, that it can
okay.
accumulate in a single go. That can be
Oh,
also a specification.
fuel
And
capacity
long ride,
is correct. Fuel capacity is, for example, 13 liter is a correct
yeah.
specification. But what you said earlier is like it can go long run. That actually does not define anything for you to design.
Okay.
Okay, you can say that engine, the mileage. You can say mileage is something like less than 30 kilometer per liter. That is a measure of specifications. Okay, that means long run. Fuel capacity, that means long ride. Again, luggage carrying capacity. Luggage capacity, for example, if you are going to long ride, you are taking 50 kg luggage at least for your livelihood. That's why these three specifications can define one particular need. Okay, so when we actually, so the reason why I gave these examples, why I ask you this question, is to understand that you know one particular need statement can leads to multiple product specifications. For example, easy to balance can be height also, weight also, and lot of things, and a handlebar distance, all these things. Similarly, comfortable seat cushion, shock absorption, then much of feeling we have stance, thumb sound. So one particular need can have multiple product specification. Similarly, multiple needs can have can be related to single product specification. For example, seat cushion, okay, is also required. Good seat cushioning is also required for long ride capability. So in both way, needs, basically multiple needs can have single specification. Okay, this is one thought. The other thing is like single need also can have multiple specification. Okay, okay, let's move to the next section. So what we do, like how actually we arrive at a particular set of specifications. Like it's not like directly we can actually arrive at so many different for a single need we can arrive at so many different specifications.
Yes, yes, sure.
Okay, so how to select like which one all we need to consider. Okay, because at the end you need to design something and you want to sell this in the market for profitability, and these needs, there are several such needs that you actually gathered from customer, and for each need you can have so many different specifications or matrices. Okay, so how to select? Okay, so for that we do something called benchmarking. So do you know what is benchmarking? We
Benchmarking, in my view, I don't know actually exact meaning, but I guess this is a ranking system. How one need is more important to the others need, maybe.
Okay, so there are two things. One is like benchmarking is done to understand which all specifications are actually and the competitors are using. Okay, so we have certain needs. For example, these are needs. Okay? One, two, three. These may leads to, you know, 15 specifications or no matrices and values. Now what we do, we compare, we check the existing competitors, what all they are trying to address. Probably they are trying to address a few of the needs, but within that few, what all specifications they are actually fulfilling. That's one goal for understanding benchmarking. uh, so how we do that? So first what we do here is, like, as soon as we have the our need from customers, we first try to rank them according to customer requirements. Okay, and according to our understanding of the interpreted needs. Okay, for example, for a classic bike, and probably the most important thing is like comfortability. So you gave a highest rating, so 5 is highest and 1 is lowest. Okay, so this is just the example. So here you give 5. Easy to balance, probably you give 2. Macho feeling, probably for a classic bike, everyone, it's more, it's like a constant need, so you have to give some good ranking. Similarly, long drive capability, you give 4. Easy service, you say 3. Easy to transport, you do not do that often, so you gave a little importance. Now you check what the competitors are doing, and how, what sort of review they got from customers. So can you name few bike companies, the classic bike companies?
First one is Royal Enfield.
Royal Enfield.
Yeah, I guess Honda also provide classic bikes.
Honda have one, very new one. And let's see
Yeah,
Java.
and
Okay.
in yeah,
Okay, so what we do here is basically we see easy to balance. Okay, we actually do a customer review, and we go to the users who actually use Royal Enfield bikes. We ask them, and we try to know the rating they want to give, in a scale of 1 to 5. For example, they give, for Royal Enfield easy to balance, they give 4 star. Okay, similarly for company like Honda, easy to balance is 5 star. Okay, for Java, these are just examples. Okay, 3 star. Comfortable to ride. Okay, comfortable wise, Royal Enfield get a 5 star, Honda get a 4 star, and Java get a 3 star. Need much of feeling. Now you are talking about now the sound or the stance. Okay, so many people think like the Royal Enfield is still, holding the capturing the market in a unique way. Still, it is the market leader. So many people will give 5 star. Probably Java they will give 4 star, and then Honda 3 star. Long ride capability, all are same. So you can give 4 star to all. So this is similar to like how in Amazon you get to know about the customer feedback. However, in Amazon, since it's a online mode, you get this information automatically. However, in a physical product, you either get feedback from customer, whenever the customer come for service, they come to the service center. Okay, so like that you generated or gather this kind of informations. Easy to service and repair, I think Honda will get a 4 star. Royal Enfield will get a, it has much more service centers in India, and Java will have a list service centers. Easy to transport, I think again, since the distributors and network is good with Royal Enfield, you have a 5 star. Then Honda is also a big company, 4 star, and you give 3 star to Java. So what we get here is actually an understanding, like, how these companies are competing with each other in addressing certain requirements. Okay, and since you are a designer and now you are going to design a new bike, now you need to decide like what kind of, which sort of specification you should follow. It's not always like that, since RE is getting the highest in easy to service, so we need to replicate RE's service center capability. Similarly, if Honda is very good at balancing, that does not means your entire design should copy with Honda bikes. So you need to select, compromise, and design within the constraints that actually you want to uh, capture through your design, because not all designs or all customer requirements might be addressed by the competitors. For example, you have the, from your customer or the user study, probably you gathered 15 you know needs, and you found that only 6 needs the competitors are capturing. And now some of these needs, like rest 7 to 15 needs, actually can negatively impact some other needs. For example, if you say easy to balance may actually counter something like high speed. So
Yes,
like
sir.
that, since you have not considered all other needs that actually you have gathered from your contextual inquiry, you never consider as such, like the highest rating will consider in your design. Okay, however, like how the market is going trying to capture what sort of needs and how they are doing. Okay, am I clear? Okay, so let's move to the next. So what you do next is you try to establish a target specifications. Sometimes what happen, like when you uh, or go for a new product development, new product design, as a designer, you may not know the range of certain specification that that you will be looking for. For example, you may not know what should be the weight of a vehicle. Okay, you may not know how much should be the thickness. Okay, so what we have here, as we discussed previously, like from the user need, we arrive at certain specifications. Okay, and these are having a matrix. Okay, and a unit. Matrices will have unit. Okay, and we'll try to figure out what sort of values actually the competing competitors are actually capturing in solving these issues. I already told you previously that, for example, here multiple needs can be satisfied with single specifications. Similarly, multiple specifications also can fit to single need. Okay, for example, if you see 1 and 6 easy to balance, and 6 is easy to transport, both depends upon weight of the vehicle, and the unit is kg. Similarly, height of a vehicle is is a matrix that will satisfy the needs easy to balance. Okay, then 2 is comfortable to ride, and 6 is easy to transport. Okay, Can you tell me like where this particular matrix will be useful? Damping coefficient.
In the comfort of the ride, as because sockets in sockets damping, what is the damping coefficient of the soccer, you can say, and
Okay.
it will prevent vibrations and all.
Okay. Okay, good. So basically we are addressing two needs. One is comfortability of riding and the other one is long ride capability. Okay. Similarly, macho feeling is like the thumb sound, which will be the unit will be dB. So now you are trying to capture certain matrices that actually these companies are using. You can have lot of matrices as we discussed previously. You may remember here we discussed about so many different seat cushion, shock absorption, foam density, but not all are used by competitors. So you considered only those matrices which are actually used by other companies, and you want to see what sort of value or specification they have come up with. For example, weight of the value. For example, this is Royal Enfield. This is your Honda. This is your Java. So for weight, RE is 156, Honda is, for example, 160, Java is 180, and now you see, again height of the vehicle can be like at 120 mm. This is 130 mm. This is 140 mm. So likewise, you try to fill all these information to understand where the competitors design specifications come into picture. So why you are doing this? Any answer?
To compare to where what actually different specifications in terms of values, what different companies are providing us, what the customer is having more satisfaction in which metric value.
Yes.
From this we can compare if the height is 1200 mm or in 1300 mm, more customers are more prone to which side, 1200 mm height or 1300, so we can get a better understanding in the terms of values.
Yes. So basically, as a designer, we may know who is performing like in the previous, this table, we know like who is doing what, which company is satisfying mostly which need. Okay, that understanding we had from benchmarking. Next, when you compare the matrices with their values among the companies, we'll know that why that particular company is who is capturing these particular needs, like here like Honda is 5 star. Okay, now one is satisfied here by how many needs? See, one. Okay, so basically height of the vehicle and weight of the vehicle for Honda is something that you should be considering, right? Because just try to analyze this. We found that customer rating for Honda is 5 star when it is easy to balance, right? And when we come to the specifications, we see that one, this first need is addressed by these two matrices, right? Height and weight. And for Honda, since Honda is the 5 star rater, this is the sort of values they have used in these specifications. So that is something how we are actually going to target our specifications. Got it?
Yes, sir.
Okay. So what we do after we analyze all sort of values, we come up with the ideal and marginal acceptable values. So we have here another chart where we have the need statement, we have matrices, we know the importance. Okay, we already discussed about that, previously. And now, we see, like, for Honda, 160 130 is 5 star. That means we should be getting some value at something like 160. So ideal value is 160, 130 is your height. Okay, because why? Because the 5 star is Honda. Got it? Similarly, if you go for cushioning, see 2 2 and 4 4. Check who is winner at 2 and 4. See, 2 is Royal Enfield is winner, okay, and 4
Yeah,
is
Royal Enfield is the winner.
a long ride capability. Who is the winner? I think everyone is same. Okay, so you can consider any one of them. Okay, for long ride capability, anyone is same. So now you go back and see 2 4 cushion thickness. So cushion thickness for Royal Enfield is the winner. So probably they will have the most thickness. For example, greater than 30, this is 20, this is 10. Similarly, 4 is equal for all. So damping coefficient is less than 15, less than 15, less than 15, right? Because you have said the comfort is long ride comfort is same. That means they are almost equal. However, Royal Enfield has a greater cushion thickness. That's why we are getting more comfort. So for ideal value, again we say like cushion thickness should be greater than 30 mm. Okay, similarly we set some ideal values like damping coefficient probably less than 13, thumb sound again decibel greater than 60 dB, parts number. So 5 6. See what is 5 6? 5 6 fewer parts. What is 5? 5 is easy to service and easy to transport. Who is the winner? See, Royal Enfield is the
Royal
winner.
Enfield. Yeah.
Royal Enfield is the winner. And what specification they have for that number? So number of parts probably they have less. So if you say 8 parts, probably they have more parts. Okay. So we take this value as our ideal value. Okay, similarly luggage capacity 4, lot of like 4 is addressed by uh, how many for need 4.
Royal Enfield. Yeah.
Yes,
In
Royal
this
Enfield,
also.
right? Royal Enfield is the winner. So you consider the value for Royal Enfield. So you say Royal Enfield can, you can carry 60 kg, they can carry only 50 kg, 40 kg. So you consider that as a ideal value. Okay, now marginal values are those values which actually are less than or greater than the ideal value because of certain constraints, design constraints, because these are not all the needs that actually your product is going to fulfill. You may have another set of needs. Okay, for example, you want a bigger engine, more powerful engine, so those are not taken care by these competitors. So in order to address that, probably the weight of vehicle will go up. Okay, because you are introducing another need. So you need to consider that ideal value is 160, probably till 165, you will consider. So you say less than 160 to 165, that's the value you'll be considering.
Is this marginal value is just like tolerance which we can provide to our product with the terms of ideal value?
Yes, yes, it is more like compromising on the other needs and your design, because not everything is derived or from engineering requirements. There are some aesthetic elements also involved, which may come from your ergonomics or industrial design perspective. Then there, for example, the new style of the bike is very something like the seat height needs to be very small. Now, in order to increase the seat height, you cannot make the tank height a bit more taller. Okay, probably in order to accommodate both, the fuel capacity you need to reduce. So all these adjustment you need to do. Did you understand?
Yes, sir.
Okay, for example, height of the vehicle is benchmark is 130. This is ideal. But your new design is so different than the other design that if you want to accommodate that particular design, either your wheel size needs to be very small, or your fuel, if you want to keep the same wheel, then probably in order to achieve the same design, you need to reduce the fuel tank size. So that's how you compromise, and you select certain marginal values as constraints to take care of other requirements. Okay, so this is how you luggage capacity 40 kg. However, since your now seat height is less, you cannot keep more luggage. Okay, so that means your 130, so you will consider 125. Okay, greater than 125 will consider. That means luggage carrying capacity will reduce. That means it will be 30 plus. Okay, so like that you uh, alter your specifications from ideal because of other requirements for your design. Got it?
Yes.
Okay, so final stage, what you do here is to reflect, to provide your critical analysis on all the three steps you did previously. What you did previously, first thing you did is benchmarking. So benchmarking will let you know who is the winner for a need, for a particular need. What you do next, establishing target specifications. So there you do establish target. This is the second thing you do. What you know from that, you know the particular value or value range, and who is the winner again. Okay, third is ideal and marginal. Okay, set ideal and marginal. What do you know from that, like what should be the ideal values, and what, because of design constraint, what should be your marginal values. Okay, so that's what you gather till step 3. In step 4, you try to understand if there are unsatisfied or you know uh, unconsidered customer needs because of competitive analysis, you did not consider those, or you gave a lower specification to them because your design goals may be different than what the competitors are providing. For example, when Royal Enfield developed this RE3 RE bullet bike, it was a city commuter. But if you are designing something more like a cruiser for long ride, probably now you need to think about a longer wheelbase. Okay, for example, this is the bike. Now you have a longer wheelbase because you want to sit in a more comfortable way. Okay, sorry for my drawings. Okay, Yeah, so you are now relaxed, you are sitting in a relaxed position. So that means you have not considered, or you have not considered right specification for this particular specification or matrices. So wheelbase you consider something like a from Royal Enfield, okay, because previously you thought like long ride capability. What you considered there for long ride capability? You
Mileage and this
yes,
fuel tank
cushioning.
capacity.
Yes, so you did not consider that the wheelbase, could be also longer for more comfort, for more ergonomics, stance. So due to that, you need to in step 4, you need to consider those unsatisfied customer requirements, and then try to understand the interrelationship between the needs. This particular need may actually affect some other needs, probably balance, easy to balance. It may have a negative correlation with the easy to balance. Okay, similarly, this may also decrease the luggage carrying capacity, because you are taking the whole spaces to get a comfortable stance. So all this analysis you do in stage 4 by a method called quality function deployment. Okay, so whatever data you gathered previously, you finally put into this particular graphical model. This graphical model is called house of quality. So quality function deployment is a method, and one of the graphical representation is house of quality. Am I clear these two things?
Yes, sir.
Okay. So what we do here is we get the needs, okay, in from our step 1. We rank there like 5, 4, 3, 2, 1, like we rank the needs. Okay, then we have the specification, right? Here we have all the specifications. Specification means the weight, okay, the height, okay, coefficient, spring coefficient, all these are there in the top. Okay, now in this there is something called relationship matrix. Okay, as I told you before, that single need can have multiple specs. Similarly, multiple needs can have single specs. Okay, that means what we do in relationship matrix, we try to see here for a particular need which all specs we need to fulfill. Okay, according to their importance, we graphically mark them. For example, if it is okay, let's go to the next page. This is a better. Okay, okay. uh, so this is house of quality matrix. So let me illustrate the example here. So easy to balance, we already ranked these, right? We ranked that easy to balance is 3, comfortable to ride is 4, neat macho feeling is 4, long ride is 5, easy to repair is 3, easy to transport is 2. So these are the importance of the needs. Okay, now accordingly we generated these sort of needs. Okay, these are the needs we generated from competitive companies, and then we also have some set of the other needs that actually are not satisfied by the competitors. That is like unique value proposition you have. Now what you try to see here, like easy to balance, like weight of a vehicle. Yes, you graphically represent this. Okay, height of a vehicle, easy to balance. Okay, maybe. maybe. So you do not, you can represent it by something like a non-solid circle. Cushion thickness easy to balance, I cannot, there is no relationship. And damping coefficient easy to balance, no. Thumb sound, no. Fewer parts, no. Luggage capacity, no. And others, no. Comfortable to ride, comfortable to ride, probably height is one. Okay, not very important relationship, but you have some relationship. Comfortable cushion, yes, very important. Then damping comfortable, yes, important. Thumb sound, no. Fewer parts, no. Sorry, this will not come at all. Luggage capacity comfortable, no. Need macho feeling, so macho feeling will be only thumb. Okay. Then you have long ride capability, long ride capability is cushion, yes, one. Then the luggage capacity is one. Then damping coefficient is one. Okay. Easy to repair, fewer parts is one. And nothing. Easy to transport, fewer parts. Okay. Did you understand this particular relationship matrix? So this is what we call is relationship matrix. We try to understand from here, like who is mapping what, like we try to see here. If you see vertically, weight of the vehicle influence what, height of the vehicle influence what. Can you see these relationships?
Yes, sir. I can
Yes,
see.
see, cushion. So you can, so it's a better way of analyzing things. Probably what it was difficult for you to analyze initially, when I try to let you understand that okay, Royal Enfield have a it's 5 star. Then we collected the value from Royal Enfield, and then we put at the end as our ideal value. So all those analysis will be easier if we follow this quality function deployment tool, which is called house of quality. Okay. So you now
So, what is
see,
the function of this direction and other specifications, that other metric values which are given here, that is a direction and competitive specification?
yes, I'll
And
go slowly. Okay. Now see, uh, once you have this, okay, this is like you now try to map both way. Long ride capability, okay, is addressed by what all specifications. See, long ride capability is addressed by cushion thickness, damping, as well as luggage, right? Similarly, from the other direction also, height of the vehicle addresses these needs. You can look both way. This is a better way to visualize the dependencies between the specification and needs. What you do next is, here again you have the companies RE. You already did this, like in step 2. This is RE, then you have Honda, then Java. So we have here the uh, benchmarking informations.
yeah, just like in step second, we are benchmarking all the needs here, right?
Yes, so we have like 5 star. Okay, this is like 3 star. That's example, 2 star, 1 star, 1 star. So all these are here. Okay. Now what we do next here is, now this is step 1 what we did, right? This is like the initial stage before we go for
Yes, it
benchmarking.
was a
Yes,
step first. After this, we done the metric part,
yes.
assign the value to specific
Hmm.
specifications.
This is RE, again RE, Honda, and Java. Now you enter the specifications that RE has come for this particular weight. So you said RE weight is 160, height is 120, like Honda is 160. So all this section you are actually doing the step 2, target specifications. Okay, and you then map here the ideal, the ideal or which one?
Ideal one, because in difficult ranking we might be putting the marginal value, right?
Yes. So ideal or marginal you can choose. Okay, so sometimes you can choose ideal, sometimes you can choose marginal. Okay, and you do the difficulty ranking. And while doing this, when you choose something like ideal, this direction of change is no change. Okay, however, when you say you are now increasing the the ideal value, then you say the direction is up. Do you understand? Because of your design constraint, you are now changing these parameters.
Sorry, can you explain this again? This direction concept. I'm a little bit confused in this.
Okay, so weight of the vehicle. Okay, the ideal weight of the vehicle should be, for example, you took the benchmark for 160, right? But the marginal value is less or increased because you have added a new engine. Okay, now marginal is 165. That means you are representing that the direction of change of this particular parameter is upwards. That means you are increasing this particular
Okay, okay.
value.
It's just like increasing value or decreasing value. In which direction we will be more beneficial, right?
Yes, so this is increasing, this is down means decreasing. Okay, that means compared to this particular direction suggest your design specifications and how in comparison to the competitive products your design specification have changes in a more graphical way. See, imagine I can write this in a tabular format. So you have weight, height, cushion, damping. Okay, now ideal value, which is basically you set after your analysis, competitor review and competitor specification, you set certain. Okay, 160 or 160, height is 120, cushion is 30, like that. Okay, now because of the constraint you have now changed to a marginal values. Okay, that's what you are representing like this. By looking at this, you will know that which feature you have increased compared to ideal. Do you understand?
Yes, sir, I got. Yes, sir, I got this point actually. Yeah.
Okay, so this is the matrices, this is the direction of change for getting these marginal values. Okay, one more thing is, like, since you have not considered the interdependency or relationship between the matrices, there may be positive correlation or negative correlations. Because of that also you need to change these values. For example, if you see, let's see, for example, I talked about something called wheelbase, right? For example, this is wheelbase, probably wheelbase, and the way height have some sort of negative correlations. Okay, similarly luggage capacity and luggage capacity damping. Okay, so more luggage capacity means you need more damping coefficient, like higher damping coefficient, so you need more good shock absorber. So these are positively correlated. Do you understand?
Yes, sir.
Yes, that means what? If you want to fix something, if you say that luggage capacity I will fix ideal, that means you need to increase your damping coefficient. So those decisions you make by doing these correlations between these features. So that's why this quality function deployment, or this, this graphical representation, which is called house of quality, is very important in detail analyzing all the findings that you have identified initially in step 1, step 2, and step 3. Did you get it?
Yes, it's a very beautiful representation of all the needs and the quality function relations in a single diagram.
Yes.
We can get all the information from this house of quality. Yes.
Yes. So sometimes there can be negative, there can be positive correlation, there can be no correlations. When there is no correlation, you do not write anything. Okay, you do not cross, you do not even put a cross mark. So this is how actually you analyze your design specifications, and then you move further for your concept design phase. Okay. So I hope this session is beneficial for you, and that's the end of today's class. Okay, so thank you. If you have any doubt, please feel free to ask.
Yes, sir. Thank you for the this session. Actually, I didn't know that there was any live session also. Just in the afternoon, I got to know it about this, and
Okay,
it was really beneficial for me to get the interaction on live classes.
okay,
And hopefully, I will be surely I will be surely attending. Will be attending future live classes also.
okay. So every Tuesday, I will
Yeah.
take the live sessions 6 to 7, and I'll be covering the concepts in a more practical way, and this will help you in solving the assignments for today's session is for fifth week assignments. So tomorrow is the deadline, so if you have
Okay.
time, so you please solve the assignments. Okay. Okay,
Yes,
thank
yes,
you.
surely, sir. Thank you for the lecture. Yeah.
Thank you. Thank you. Bye.
Bye.